Hello, welcome back. In this segment, I want to discuss an interesting difference between two expressions, 1 minus 2 and 1 plus minus 2. They both are essentially the same mathematically, right? 1 minus 2 should give you minus 1 as an answer, right? And well, this is minus 1 and this is also minus 1. Okay, let's see in terms of the flags, are there any differences between these two expressions? So I'm going to write an expression for 1 minus 2. I'm also going to write another expression for 1 plus minus 2, right? And I wanted to see whether any conditional codes are different between these two expressions. Okay, so let's get started. I have put 1 to ECX and 2 to EDX. This is AT&T syntax. So this is the destination. So ECX will be ECX minus EDX. So which means we can rewrite this as ECX is equal to ECX minus EDX, right? That's the meaning of the subtract statement. Okay, which becomes minus 1 as we expected. Okay. And what about the next expression? The next expression we need to model is 1 plus minus 2. So move 1 to ECX. Okay, move minus 2 to EDX. And instead of minus, we are going to use a plus. So it's add. Okay, so we expect here the same with AT&T syntax. This is the destination. So ECX will be ECX plus EDX, which means it will be 1 plus minus 2, right? In this case, it's 1 minus 2, which is minus 1, right? Okay, and in this case, it should be ECX plus EDX, which is 1 plus minus 2. Okay, mathematically, they are same. Therefore, we expect the answer to be minus 1 also here. All right. Now let's check in terms of flags that are enabled after the subtraction instruction is executed and after the add instruction is executed. That is the goal. Okay, let's get started. I'm going to load this into GDB. I already compiled it, and I will show you how the flags will behave. Okay, I already compiled, linked, and everything, and I got an executable add versus sub. Okay, disassemble my assembly that I have just discussed. Right away, you notice one thing. When you disassemble my code, the value minus 2 is shown here by GDB as FFF, FFF, and so on, E, right? That this is essentially the same as minus 2. It's just a minor note, okay. But I wanted to put breakpoint at a few places and study the behavior. So first I argued that let me put the breakpoint at the instruction before the move 1 is, oh, yeah, that's fine. Before the move 1, right? And look at the flags that are enabled after the sub instruction is executed, right? Let's do that. Run. And let's print the flags. Okay. We can note that we have done 1 minus 2, right? Okay. What are the flags that are enabled? Well, first we can check the answer, by the way. Answer is -1, which is same as CFFF in hex representation. Okay. So we did 1 minus 2, and we got all these bunch of Fs. That's basically -1. All right. If you wanted to interpret it as a signed number, it's -1, or it is a U int max in case of unsigned. Anyway, so 1 minus 2 is perfectly done. But look at the flags that are enabled after the 1 minus 2 expression. The carry flag is look at the flags that are enabled after 1 minus 2, right? The carry flag is enabled. Okay, we don't care about parity flag and earth flag for now. Signed flag is also enabled, okay? Interrupt is not interesting for us also for this portion of the discussion. So carry flag is enabled because you cannot subtract 2 from 1, right? 2 is larger than 1, so you can't subtract. Okay, that is the reason you need to have a carry. And that's the reason why carry flag is enabled. And the sign flag is enabled because the answer is a negative number. 1 minus 2 resulted in -1. Therefore, we have a sign flag enabled. Okay. Now let's continue so we are done with 1 minus 2, right? We used 1 and we used 2, and then we did a subtraction. So let's do the same for 1 plus minus 2. Okay. So I did use 1 here, move 1 to ECX. for -2, I moved here to EDX, and then I'm using add now. Okay, let's put a breakpoint at this location and study the behavior of the flags. Okay, let's do that. So I'm going to put a breakpoint after the add instruction is done, and I'm going to print the value that is stored in ECX to just show to you that it is still -1. Yeah, it's still -1. But I'm interested in flags more specifically. Look at the flags that are enabled. Okay, in this case, the important thing is carry flag is not enabled. Okay, so what is the reason carry flag is not enabled when we do 1 plus -2? The reason is simple. Remember, -2, as I have shown in the assembly, is treated like a large positive number, right? When we did 1 plus, 1 is nothing but 0, 0, all the way until 31 zeros and then a 1, right? -2 was represented as 1, 1, all ones, and then a 0, right? Now you can safely add these two, right? Okay, if you add these two, you get all ones. Okay, and there is no carry here. There is no carry. That's the reason you don't see carry flag. Of course, the signed flag is turned on because the answer is having the most significant bit turned on.